At least now, if you tune in, you'll get to see the answer. We feeling okay with that one on the left? So it's been a while since we've done proofs. In all honesty, that's a pretty easy proof on the left, but relies heavily on your formula sheet, which might make it tricky. When you get to those moments of like desperation, like try to look at your formula sheet and see if you can't find that pattern somewhere. I suspect that like at this moment there would have been a lot of people who like what do I do now, right? There's no fractions to combine. I have everything in sine and cos. Like go look at your formula sheet until you can figure out that pattern somewhere or something to do with it. What you don't want to do is you don't want to turn things back into tangents. Don't turn things into like secants or cosecants. Like try not to make it more complex. Okay, let's do another one. So, looking at B. Pick the side that looks more confusing. Fair to say the left side looks a lot worse? Yeah, I agree. So, we're only going to manipulate the left side of that equation, not the right side. When manipulating the left side, first thing I'm doing is I'm changing everything to sines and coses. So anything that is not sine or cos, I'm changing to sine or cos. That's quite a few things here. So I have cos theta, that's obviously okay, plus cotangent theta. That needs to change. That is cos over sine. That's my new numerator. The denominator. I have secant theta, so secant needs to change to become 1 over cos. Plus tangent of theta, that is sine over cos. So step 1, sine and cos. Perfect. Step 2. You are going to add or subtract any fractions that you have. I didn't have any in the last question to add or subtract, but on this one I do. So I'm going to add or subtract my fractions. To do that, I need a common denominator. I'm going to add the numerators together first. I can't add the numerators until they have a common denominator. To get that thing a common denominator, I need to multiply this thing by sine theta top and bottom. Right, this one has a sine theta on the bottom. That means this one needs a sine theta on the bottom. Looking at the denominators, they already have a common denominator, so I don't need to do anything to that one yet. So I now have cos theta sine theta over sine theta plus cos theta over sine theta. Over, the denominator has not changed. Common denominator achieved. Now, add your fractions. The numerator, that will become cos theta sine theta plus cos theta over top of sine theta. The denominator is going to be 1 plus sine theta over cos theta. I now have a numerator that is one fraction. I have a denominator that is one fraction. To divide fractions, I kiss and flip. What was Blinky saying? Flip the guy and multiply, right? Like, whatever's going to get you to be able to actually divide these two fractions together. Yes, sir?
Before we do that, would we want to cancel out the two sines on the top? Or the two sines?
Those can't cancel out. That's a good question. Because the numerator has an adding up here.
Oh.
So that's a binomial, which means the only way to simplify this binomial is to be able to cancel out the whole binomial, which I can't do right now. Okay, so we're going to flip the guy and multiply, or kiss and flip, which is the way Cooler is saying. So the first fraction is cos theta sine theta divided by, plus cos theta divided by sine theta multiplied by the second fraction is cos theta over 1 plus sine theta. Yep. On the top, yep, we're definitely going to need to do that. Yeah, and you could have done it before and it would not have been wrong. Okay, I get to this point. At this point, you're desperately hoping that something will cancel out. Like something in the numerator will cancel with something in the denominator. And the way that it currently looks, it doesn't do that. But what you do have in the numerator of the first fraction is you have the ability to take a GCF of cos theta out. If you were to take a GCF of cos theta out, I would be left with a sine plus 1, which would cancel out with this sine plus 1 over here. Right? When you are looking at this stage, you want something to cancel out. In a bad way, you're hoping something's going to cancel out. So if you can turn something into 1 plus sine, you definitely want to do that. This, by GCF being a cos, leaves you with a sine plus 1. And then those things can simplify. So I would have this. Cos theta comes out. I'm left with sine theta plus 1. The denominator is still sine theta. On the right-hand side, I have cos theta over 1 plus sine theta. These two things, this binomial on the bottom over here and this binomial on the top, can then simplify. I know that one is sine plus 1, the other one is 1 plus sine. It's the same thing, right? Addition, you can switch the order of it and it doesn't matter. Yes, sir. Yep. That leaves me with cos over sine times cos. If you look at what our goal was to get to cos times cotangent. I have that. This is cos, this is cotangent. So I can change it. Cotangent times cos theta. My left side now equals my right side. Good question. If that was a diploma question, you have a full page. Yeah. So you'd have lots of room. With that being said, if this was like a regular test question, obviously we save some space here. I want you to write both sides of the equation every step. We obviously didn't have room for that on the second question, but look at the first question. See how I wrote both sides the whole way? That's how it should look. We just don't possibly have the space to do that here. We take a full page. On your diploma, you have way more than enough room. They always leave an excessive amount of space, especially for written response questions. Like I've seen them have written response questions that take like one line and they give you a whole page. Yep.
Question: is there a Scantron in the diploma, or is it just like?
You know, like the one I give you guys for tests, it looks exactly like that. So like it's literally the exact same bubble sheet. Yeah. And you can't use pen. You didn't even hear me. I said you can't use pen on the diploma. Good. Progression.
Yeah, it was a gift from friends because he was tired of using pen.
It's a good friend. Alright, let's check this one. Number 4. The exact value of sine 75 can be determined using the expression. Okay. The number one answer here is definitely A, where people are like, oh yeah, 75 is 90 minus 15, and they just put sine 90 minus sine 15. You got the right idea, but you're just like slightly missing it. When we see exact value questions, that usually tells us to use the unit circle. Typically, in trig, exact value, that screams unit circle. Then they give me sine 75, which is not on the unit circle. So our goal is to write 75 as two values, either added or subtracted, that are on the unit circle. So for instance, on unit circle, you know 0, 30, 45, 60, and 90. So is there some combination of those values that could add or subtract to be 75? What is it? Which of those numbers could add or subtract to be 75? $90 and $15 would work. 15 is not on our unit circle though. What was the second one you said? 45 and 30 would add to be 75, and they are on our unit circle. So what we would want to do is we would want to take this sine 75, and we would want to rewrite it like this. Sine 45 plus 30. Those are both values that are on your unit circle. Notice that I didn't write sine 45 plus sine 30. I put sine of 45 plus 30, and the 45 plus 30 is in the brackets. This is on your formula sheet. Right? When we have angles that get added or subtracted together, there's a formula for that. If you look over here, you will see sine A plus B equals, and then they give you that big spiel. So for us, if we use that formula, sine 45 plus 30 would become sine of 45 times cos of 30 plus plus cos of 45 times sine of 30. Hopefully that's one of the answers there. It is. It's C. Now, why would that be useful to you? It's like if this was a written response question, they could definitely ask you that, the exact value of sine 75. Why would we want to change it to something that's on the unit circle?
Points and the radius or the
hypotenuse?
Yeah, because now I can go to all these values, and I know exactly what they equal. I know that sine of 45 is root 2 over 2. It's the y value at 45 degrees. I know cos of 30 is root 3 over 2. That's the y value, the x value at 30 degrees. I know cos of 45 is root 2 over 2. That's the x value at 45 degrees. I know that sine of 30 is the y value at 30, which is 1/2. And then I could actually change all of these to values, and then I could calculate the value of sine 75, because it's equal to all those things together. So if this was a written response question and we had to keep going, I'm going to do it in red because we don't have to keep going. It's multiple choice here. But if we did have to keep going, this would be root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1 over 2. Right? I know what every single one of those things actually equals. I had no idea what sine of 75 equaled because I didn't know the y value at 75 degrees. But I did know all those values because they were all in the unit circle. That means this is root 6 over 4 plus root 2 over 4. Add those together, it would be root 6 plus root 2 over 4. That would be the exact value of sine 75. Question 5 is pretty much asking you the same thing. Determine the exact value of sine pi over 12. Pi over 12 is not on my unit circle, but exact value pretty much tells me I need to use my unit circle. So I need to try to rewrite pi over 12 as two values from my unit circle. That's a little bit trickier because those are radians, right? So radians that I know 0 radians. I know pi over 6 radians. I know pi over 4 radians. I know pi over 3 radians. I know pi over 2 radians. You know beyond that as well, but typically you can just do it in the first quadrant. Because our goal is to be pi over 12s, you could rewrite all of these as pi over 12s. The first one would be 2 pi over 12, right? Because I had to multiply the denominator by 2. The second one would be 3 pi over 12, because I had to multiply the denominator by 3 to get to 12. The third one would be 4 pi over 12, because I had to multiply the denominator by 4 to get to 12. And the last one would be 6 pi over 12. And maybe that helps now. I'm trying to find two values that I could use to add or subtract to become pi over 12. Any suggestions? Yep.
If you subtracted 4 pi over 12 from 6 pi over 12, that'd be 2.
That'd be 2 pi over 12. Yep. But you're on the right track.
Sorry, if you did it with 3 and 4 on that.
3 and 4 would work. So I could rewrite pi over 12 as 4 pi over 12 subtract 3 pi over 12. If I had 4 minus 3, that would leave me with 1 over 12. I also could do 3 minus 2. So there's actually two answers here, right? I could do 3 pi over 12 minus 2 pi over 12. That would also leave me with 1 pi over 12. Either one works. Let's do 4 pi over 12 minus 3 pi over 12. Okay, again, pi over 12s aren't on my unit circle. But I got 4 pi over 12 from pi over 3, right? I could reduce it. So let's rewrite it back as unit circle things. That means this is actually pi over 3 minus pi over 4. From there, that doesn't just split apart into sine minus sine. You have to go to your formula sheet, and you have to look for sine of an angle minus another angle. It's right here. Sine of an angle minus an angle equals all of this. So I got to write out all of that. It's sine A cos B cos A sine B. Okay, it looks like this. Sine of the first angle times cos of the second angle minus cos of the first angle times sine of the second angle. I now know all these values. This means the y value at pi over 3. I can figure that out. This means the cos value at pi over 4. I can figure that out. This is the cos value at pi over 3. I can figure that out. This is the sine value at pi over 4. I can figure that out. Right? If I go ahead and I solve all of those, y value at pi over 3 is root 3 over 2. Times the x value at pi over 4, that's root 2 over 2. Minus the x value at pi over 3 is 1/2. Times the y value at pi over 4 is root 2 over 2. Multiplying those together, that's root 6 over 4 minus root 2 over 4. My answer is root 6 minus root 2 over 4. Yes, sir.
So the only way you'd be able to put something there that isn't a fraction is if it was an exact value.
Yeah, sometimes you get like, they'll do 90 degrees. And sometimes with 90 degrees you get like ones or zeros, right? And then it's not so bad. If it's pi over 3 is pi over 4, so you're going to get fractions. It just kind of becomes inevitable at that point. All right, number 6. The expression they give us that big mess is equivalent to. I actually thought about deleting this one off because I was like, I don't know if I like it that much. But then I think it reviews a couple of things that are probably worth reviewing. We got the square root of something. So what I think most people would want to do is they would want to square root everything. They'd want to square root the 1, square root the tan squared, square root the 1, square root the sine squared, which is actually like no bueno. That's not good to us. That's just not how roots work, right? Like you can't just distribute it into everything like that. Instead, when I look at this, I'm going to see if I can't simplify that radical on the inside a little bit. If I can't make that radicand maybe a little bit more simple. So looking at the numerator, I'm going to look for 1 plus tan squared on my formula sheet. I'm going to see if I can find that somewhere. You do find it. It says 1 plus tan squared equals secant squared. That is on your formula sheet. So that means I can change this numerator to be secant squared. The denominator, we already had that one earlier. If I see 1 minus sine squared or 1 minus cos squared, that's one of our formulas. It comes from sine squared plus cos squared equals 1. Right? You can manipulate that to be 1 minus sine squared equals cos squared. So that means the denominator is now cos squared. Okay, looking at that. Now I can square root the top and square root the bottom. The difference between this step and the original question is the original question had binomials, right? Adding and subtracting. I no longer have adding and subtracting, which means now I can square root the top and I can square root the bottom. The square root of secant squared would be secant. The square root of cos squared would be cos. If we look, that does not match any of our answers. Okay, we got a little bit of a trick here. I could separate these two things to look like this. Secant squared times 1 over cos squared. Sorry, secant x times 1 over cos x. And that's the same thing. If you think about this, like I could put these two things together, right? And it would become secant over cos. So I could separate them. The reason I would separate them is because I have a 1 over cos here, which is secant. Which means this is secant times secant. Wow, that's some high quality tech right there. Secant times secant, which is secant squared x. It's just a lot of work. It is. It is a lot of work. Yes, sir.
Alternatively, if you would turn the secant into 1 over cos,
Yep.
and then wouldn't the coses cancel out and you'd be left with 1?
You'd have 1 over cos times 1 over cos, which would become 1 over cos squared,
Oh.
which then becomes secant squared.
Okay.
Yeah. Trig is just a lot of work. And we're not talking like working out watching Cocomelon work. Like real work. Like the work y'all gave Rocky last night for free. Ethan still doesn't get it. That's okay. Question 7.
No.
He's like, I do not understand. I'm more hip than Ethan.
I wouldn't be surprised.
I was talking about the song Air Force Ones this morning, not one person knows it, so. Yeah.
With these equivalent expressions, are you able to just interact with them?
Yeah, you could. Like, you're not wrong. He's asking, like, if you have an equivalent expressions question, you could just calculate them and figure out which decimal's the same. That works. Or put a value in for x and calculate it and see if which one's the same. That does work. When you get these equivalent expression questions, there's a good chance that they will have worked around that, though. Usually they'll make it a numeric response, right? And they'll be like, the value inside the bracket would be, like one of those. Or it would be a written response. Yeah. It's pretty rare these come out as multiple choice because of that. This one says the expression cos squared 4 pi minus sine squared 4 pi is equivalent to. Okie dokie. What you can't do here is you can't just subtract those things and put them together, which sometimes just becomes people's go-to. If you get desperate, you are going to look at your formula sheet and see if you can see cos squared minus sine squared anywhere. When you look at your formula sheet, I don't think you do see that anywhere.
No, there's a cos squared minus
Cos
sine squared.
Is there?
those two angles.
Oh yeah, down there at the bottom. Good call. So it's got to be somewhere. Right here. Cos squared minus sine squared will equal cos of 2a.
You think so?
So we do see that formula. Perfect. So that means this thing is A. So if I want to combine these together, I need to double A. So this becomes cos of 2 times 4 pi. This is cos of 8a. Or sorry, 8 pi. C. Well, that was much easier than what I was about to do with it. It's going to get a lot worse. Perfect. Number 8. The expression blah, blah, blah is equivalent to. Okay, first thing you're going to do, change your tans to sines and coses. Looking at this, that means I'm going to now have sine x divided by sine over cos. I'm also going to change my 1 over secant x to be cos x. You could change it to 1 over cos, and then you would have to kiss and flip and make it a cos x eventually anyway. Or hopefully we just remember, like, secant and cos are reciprocals of each other. So if I'm talking 1 over cos, that's secant. If I'm talking 1 over secant, that's cos, right? They're reciprocals of each other. Cool. At this point, I'm going to take that first fraction. I have sine divided by sine over cos. I'm going to kiss and flip so that I now have sine times cos over sine. Perfect. You should notice these sine x's cancel. So I now have cos x plus cos x. That is 2 cos x's. That is not cos squared. That's not an option they gave anyway, but sometimes people put cos squared. That's when you're multiplying two things together. We're adding two things, it gives you a coefficient. That would be like a beautiful written response question. Two left, number 9. Given sine of A equals 7 over 8 and cos of B equals 4 over 5, where A and B are acute angles, the value of cos A minus B is equal to. Okay, dokie. They told you one triangle and a second triangle. I know these are different triangles because they're different angles. One was A, one was angle B. I should sketch both these triangles. First one. Let's just build them in quadrant 1. Would have a y value of 7 and r value of 8. The second one. Build it in quadrant 1 again. Have an x value of 4, r value of 5. Yep.
How do we know that they're in quadrant 1? Whereas, like, our angle B could be in quadrant 4.
Technically, you could be in different quadrants. It should have definitely defined it. It should have said A and, well, it does say A and B are less than 90, because says they're acute angles. But like, they never say if those are reference angles, or you can assume their standard position. But I'm kind of with you. I think they should make it a little bit more clear. They'd probably say in between 0 to 90. Yeah. Okay. Why building these triangles was important? Well, they asked me to find this. Which means you have two options here. You either need to find angles A and B, subtract them, and then try to calculate that value. If you do that, it's not going to match up to any of your answers because you're going to get a decimal that's irrational. Or you have to use a formula for this. Cos A minus B is on your formula sheet. Cos A minus B equals cos A times cos B plus sine A times sine B. Sorry, those are dragging so bad. And I know what some of these values are, but I don't know all of them. Like, I know that cos B is 4 over 5. It told me that. I know sine A is 7 over 8, because it told me that. But what it didn't tell me was it didn't tell me what cos of A was. And it didn't tell me what sine of B was. But I could use these triangles to figure out what these things do equal. Cos of A means using angle A, triangle A, do x divided by r. You don't know x, so you'll have to do Pythagorean theorem, and then you could figure out x divided by r. So for triangle A, we would do 8 squared minus 7 squared equals x squared. That's 64 minus 49, which is 15. So the square root of 15 equals x. That's the world's worst 15. Try again. And now I do know what cos of A is. Cos of A is root 15 over 8. Right? It's x over r for that triangle. Triangle A. To figure out sine of B is y over r for triangle B. Looking at triangle B, I don't know what y is. So I have to figure it out. I use Pythagorean theorem. I do 5 squared minus 4 squared equals x squared. And you should get 3 equals x. That means sine of B is 3 over 5. And this can be calculated and simplified. The first fractions would become 4 root 15 over 40. The second fraction would become 21 over 40. I can add those together. It's 4 root 15 plus 21 over 40. I swear my writing's not that bad. C. I do think that, like, at the end of the day, that on a diploma would be a very hard question. There would be a lot of people who just want to get on the unit circle or try to figure it out or try to actually calculate angles A and B. Notice I never calculated angles A and B. If you see this, like, that's 99% of the time going to be a formula you need to change into this. Like, almost always. And I'm not actually calculating angles A and B. I'm calculating ratios for A and B. Y over R, X over R. That's all you need? Okay, I'll come supervise your diploma and I'll do that. I'll just walk by and whisper strategies in ears. Formula sheet.
Now we're talking.
Now we're talking. Actually, I'll just, in the next 2 days, I'll just train Mr. Hart on all of this. Because I can't supervise you, but Mr. Hart can supervise you. And he'll just walk around. All perps and columns. Every time he sees you on a perps and column question, order matter. That's all he's going to ask. Okay, I got this. Mr. Hart and I got some homework tonight. Yeah.
Alternatively, you could give him like those glasses with a camera in them and just teach him where you can just walk around and do this.
Like a spy?
Yeah.
I like that. Okay, that's a better strategy. And I can whisper his ear, like a CIA agent kind of thing. You know, have like the little hit. You see Mr. Hart walk around the library with a little earpiece in? You know that's me. Just giving out some fire tips. Why did my 15 disappear? There we go. I'm recording my scandal. No! It was all Mr. Hart's idea. I won't go down for this. His name is Jordan Hart. That's not actually his first name. That's actually his first name. Okay. Last one. Then we're done trig. And I think we're tapped out. This guy. Brain is fried. Trig has fried us all. The expression sine cos minus cosine is equivalent to this pattern. Like when you see sine cos minus or plus sine cos, like that screams this is on a formula sheet. When it just seems like too much, it's going to be on the formula sheet. Like that's a mouthful, right? If you see sine minus cos, same idea. Cos minus sine. Anytime you see like those types of patterns, like that is alarm bells all the time. Formula sheet. I don't know what the formula is, but I know that's a formula sheet issue. So I'm looking for that same pattern, sine cos minus cosine, and I'm hoping it's somewhere over here. It is. I hope. Yeah, straight down the right side, you will see that sine of an angle minus an angle equals sine of the first angle cos of the second angle minus cos of the first angle times sine of the second angle. And there's my pattern. Sine cos minus cosine. Sine cos minus cosine. The angles, this one is A, this one is B. This one is A, this one is B. So I could kind of work this thing backwards a little bit. That means my original question was sine theta over 5 minus 2 theta over 7. Combining those fractions together, I need a common denominator. That means the first one needs to be multiplied by 7. So it becomes 7 theta over 35. The second one needs to be multiplied by 5. Make it 10 theta over 35. With a common denominator, I can subtract those things. That means this is sine. Oh, I was about to freak out, but it worked out. 7 minus 10 is negative 3 theta over 35. And that is answer D. Here we go. Cool.